welcome student to this mathematical methods 1 course, where now we are in the process of learning the complex analysis. In the last class we learned a few things of complex variable, and we show that a complex variable z can be represented in terms of this. I call it variable, that is why I put x and y. Last year also I write something like a plus ib, which is the value, fixed value, but it is changing, may change, that is why I call it a variable. The same thing can be represented in terms of polar coordinate, which is r e to the power I theta. We show that how to write from here to here, so we will not going to discuss this more, but important thing is that z star was something which is called the complex conjugate, and when I say conjugate, that means I need to replace this I with a minus I, that is why this minus sign will be here. In a similar way, if I write these things in terms of polar coordinate, then this polar coordinate, this I will be replaced by minus I. So, the equation from this and this, there is a change, this changes from this I. Now, if I try to find out geometrically what is happening for this z star, so this is say my complex plane where real and imaginary axis is represented by this. I have a point z which is x plus I y, which is here somewhere x y. So, z star is nothing but the replica of this point or the image of this point against in real line. So, if this point is x plus I y, I will have another point here which is x minus y, and the point will be defined as x minus I y, which is just the image of this point against the real axis, as simple as that. Also, if I say these things in terms of theta, this is the value of r. By the way, there is a relationship between r and theta that we also derived last class with x and y. R will be this quantity and theta will be this quantity. So, now if I say this is r, both the cases there is no change, whether it is z or z star, both the cases the r will not going to change, because this is a real part. When I make a z star, this real part should not change, only thing is the angle, and if we measure the angle theta for this case from this direction, I need to measure theta in this direction which is opposite, and that is why the negative sign will appear here. So, that means this point in polar and Cartesian coordinate, if it is here, then I will have a point here which is the mirror image of that point, and that is nothing but z star. This is a few small thing that I want to quickly mention regarding this complex analysis course, which is well known, but still I believe it is important for you to make a review. That is why this is the first 2 or 3 class will be a review class. So, now z and z star can also be written in terms of x and y, sometimes you also require that. So, z is equal to x plus I y and z bar or z star is equal to x minus I y. If these two are given, then readily you can find that z plus z star divided by 2 is your x and z minus z star divided by 2 I is your y. Just a relationship between z and z star with x and y, that is all, nothing special here. Also one thing, if from this also you can readily understand that z star is equal to r e to the power I theta multiplied by r e to the power of minus I theta, which is nothing but r square. So, mod of z is equal to r. The same thing in a different way. Okay. Now, the next thing which is important, if I represent a quantity, complex quantity z, which is say x plus I y and which is r e to the power I theta, I represent this as usual. This is my complex plane, real and imaginary axis, and I say the point is somewhere here, for example. This is my x and y. Fine. Now, what is the value of theta? Theta is this quantity, right? Still there is no problem. But is this the value of theta is unique here? Because if I go with this, then again I will have a theta which is the same point, which is located the same point in polar coordinate. That means this I can write in this way also. If I multiply, if I add 2 pi with my initial theta, if I add 2 pi, then I will have a angle which is 2 pi plus theta, but this will represent the same point here. The angle of the theta is just added to 2 pi and it will represent this point. Why it is representing the same point? Mathematically it is easy, because e to the power I theta and e to the power 2 I pi, you can have these things, additional things. And what is the value of this quantity? R e to the power I theta multiplied by cos 2 pi plus I sine of 2 pi. Sine of 2 pi is 0, cos of 2 pi is 1. So, eventually I am having 1 multiplied by e to the power I theta, which is the original value, and for that I am getting the same, that is why I am getting the same point r, but theta is now changed from theta plus 2 pi. This will true, by the way, for another round also. This is one round, if I took another round, then still it is true, and so on. So, in general this equation should be represented as r e to the power of I theta plus 2 n pi, where n is 0, 1, 2, so on. So, that means this theta is not unique, this theta is not unique. If I add something, then I will get the same value of this. When I was representing a number z is equal to r e to the power I theta, when I try to write the r and theta in terms of z, then normally we wrote mod of z is equal to r. Just few minutes ago I saw that. Not only that, this theta we wrote argument of z is theta, right. Small argument of z I write it is as theta, but here I find that this theta is not a unique theta, rather 2 n pi is added over that, and this 2 n pi again give me the same point, that is why this uniqueness of theta is gone. So, that is why argument of z is represented as theta plus 2 n pi. Now, this theta, which is the value here from here to here, is called the principal value. Principal value. This principal value of theta should have some restriction, obviously, because 2n pi, if I add with that, I will get argument or argument of z. So, this theta, if I represent at a principal value, there is a way to represent it. Normally, it is represented as argument of z is argument of z plus 2n of pi. This argument is the argument of z in general, where 2n pi is added, but this argument of z is associated with this theta, which we call the principal value. Okay. So, but there is a limit. What is the limit? So, argument of z, big argument of z, which is the principal value, should lie in between pi to minus pi. This is the limit. So, theta, if this theta is in between this, then we call this as the principal value. Let us check to a few cases how these things are. So, for example, here the first theta is this one, which is in between pi to minus pi. So, for this theta, it is obviously the principal value of the theta. But if I make one round and go to this point, that means theta plus 2 pi, which is not in this range, but still this gives you the same point. So, that theta is not a principal value, but it is a value with added 2 pi with the principal value. Okay. Now, we will come to this point once again, but before that, let me write what is the point I. How to write I in terms of r theta form. So, it is 1, obviously the magnitude is 1. So, where the I locate? I is located here. So, it will be e to the power of I pi by 2. But as I mentioned, if I add 2 pi with that, so e to the power I pi by 2 plus 2 pi is also the same value, but here the value is e to the power of I 5 pi by 2 seems to be. So, e to the power I 2 pi by 2 and e to the power 5 I pi by 2, both are giving the same I. So, in one case the angle is measured from here to here, which is pi by 2, and by the way, this is the principal value PV, and other thing is adding these two. I am giving this just one example. So, that means other value is adding these two things. So, I will go here, 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 and then go this point. So, what is the value of this? 5 pi by 2, which is not the principal value, which is something added with that. Also, one thing, for example, I have one point, say z equal to minus 1 by root 2 plus I 1 by root 2. This you can readily figure out that the point. Let me first figure out the point. Minus, okay, let me change slightly, it will be not this one, let me put minus, then it will be easier. So, this is my real axis, this is my imaginary axis. So, I want to locate this point, which is easy, that I go real axis to 1 by root 2 and the same value I will go to down. So, that somewhere here, this is the point. So, what theta I will put here? The question is what theta I will put here. because if I write this so it will be just e to the power I pi by 4, because pi by 4 is 45 degree. So, it is cos pi by 4 plus I sin pi by 4. I should put a negative sign here, so that this became negative. This I can write, this equation I can write as cos of minus pi by 4, cos 45 degree, pi by 4 means what? Cos 45 degree, cos 45 degree means 1 by root 2, and sin 45 degree is also 1 by root 2, but negative sign I am taking care of this way, so that my theta become minus pi by 4. Why I am writing this equation in this form? So that I should understand that whatever the theta I am taking is the principal value, because here two way you can have this angle. First is this angle, you have this angle which is how much, 2 pi minus pi by 4, so it is 7 pi by 4, something like that, 7 pi by 4, and you can also have this quantity which is minus of pi by 4, because you are measuring this is anti-clockwise, and you are measuring this as a clockwise. So, clockwise is normally we put as negative. So, this is, but the question is which theta is the principal value. So, you should remember this thing, that argument of z, which is the principal argument, that is why this big A is associated for that, it should be this quantity. So, that means it should be greater than, less than pi by 2, less than pi, and it should be greater than pi by 2. So, 7 pi by 4 is obviously greater than pi. So, that is why this argument of these things should not be this blue one, rather it will be minus pi by 4, because minus pi by 4 is falling in this limit. So, the principal value of the angle should be minus pi by 4. That is the thing I wanted to mention here. Okay. After that, I will also like to mention one thing. This is important, this principal value, principal argument, these things we will going to use that soon. But before that, let me write something. So, z was represented by r e to the power of I theta in this form, which is r cos theta plus r plus I sin theta, this, right. Now, if I put z to the power n some value, which is obviously r to the power n e to the power I of n theta, this quantity I can write r to the power n cos of n theta plus I sin n theta. But already z is equal to this. So, when I make a to the power n from here, if I take these things, then it will be r to the power n cos theta plus I sin theta whole to the power of n. Now, these things and these things are same, these things and these things are same. If they are same, then we have something interesting, and this suggests that cos theta plus I sin theta whole to the power n is equal to cos of n theta plus I sin of n theta. And I believe all of you, those who are taking this course, are aware of this equation, this identity, which is called the de Moivre's theorem. This de Moivre's theorem suggests that if we have cos theta plus I sin theta whole to the power n, then this value will be nothing but cos n theta plus I sin n theta, which comes quite obviously. But this is a very interesting interesting identity in my opinion. Okay. So, next thing is we are still. So, next thing is few equations. So, before that, let me show you one thing, that e to the I represent I as e to the power I pi by 2. This is the representation of I in terms of exponential term. But I can also represent 1 in terms of, 1 is a pure real quantity, but still we can represent in terms of polar coordinate r theta, where r is 1 obviously, but the phase term, this is called the phase term, is say e to the power 1 is represented as, sorry, this is minus 1. So, minus 1 I want to represent. So, minus 1 is e to the power I pi. 1 can also be represented as this anyway. 1 will be e to the power of I into 0, as simple as that, plus 2 n pi, plus 2 n pi, because 0 is a principal value, and then this value is the addition. But if I put n equal to 1, then we have e to the power I 2 pi, e to the power I 2 pi will give you the value 1. So, no problem with that, but I am interested in minus 1, which is represented in this form. If you have this point here, so always I am doing this because you people, when you have a complex number, then try to find out what is his location in this complex plane, and when you have the location of this point in the complex plane, then you will have the idea what is his amplitude and what is his value. So, this minus 1 is located somewhere here, because this is a real point, it will be in the real axis, and angle if I measure would be something like this. So, this angle is pi, but the interesting thing is this equation, e to the power I pi plus 1 is equal to 0. This is a very famous and important equation, because all the information, I would like to finish this class with a note and try to make you aware of these things, that all the important terms are associated, that is associated in the physics as well as in the math is here. First of all, you have E here, second thing you have pi here, E is the irrational number, pi is the irrational number, I is the imaginary quantity, e to the power I pi is something, plus 1 gives you 0. This is the more fascinating, one of the most fascinating equation, to be very honest, in mathematics as well as in physics, because this pi e are always used in the different part of the physics. But you should also appreciate with the fact that 0 is something which is very important in the math, because this is the identity element for addition operation, 1 is identity element or multiplication operation, pi which is very important, e is very important, I is very important, all these things are together. So, 1, 2, 3, 4, 5 very important terms are together, and they are forming a very fascinating equation, something like this. So, this is just a byproduct of what we are doing, but I thought that I should mention these things, and those who are really concerned about this fact that e, pi and these things are so important, they have an equation in their hand which is associated with all the terms together and gives a very simple and beautiful form of this equation. So, with this note, so let me conclude this class here. Still in the next class we will do few things like using this concept, this principal value concept, we will find out how you can measure the root of a complex number, which is important. So, in the next class we will find how to calculate the root of a complex number and using using this concept of the principal value and all these things. So, with this note, let us conclude the class here. In this class you learn few important things, that how the complex number and the principal value and all these things are related to each other. This is nearly nothing but a point in the complex plane, and you need to know the exact location of this point, because in the future class everything will be associated in this plane which we call the complex plane, and you should have a clear cut idea about the location of a complex point in this plane. So, the theta and r is some parameter which is useful, but apart from that you should have a realization that in real case everything over the real axis, the life becomes simpler, but since it is a complex thing, so you will have entire plane where the points are located, and not only one variable is associated with that, you have two variable x plus iy. So, these two variable we need to deal with these two variable, and how this will gives you some fascinating thing we will learn in the future classes. So, with this note let us conclude this class. Thank you.